building an AI agent knowledge base, MCP, RAG, and vector databases for extended local memory. Every AI agent has the same fundamental limitation: it forgets. Each conversation starts from zero. The research it did yesterday, the preferences it learned, the documents it analyzed, all gone when the session ends. What if your AI agent could build a permanent searchable knowledge base from everything it encounters? Every web page, every PDF, every conversation insight, indexed, embedded, and retrievable in milliseconds. That's what we're building today. The stack combines three technologies. First, MCP, the Model Context Protocol. Released by Anthropic in November 2024, MCP is like USB-C for AI. It's a universal interface connecting any AI model to any external tool or data source. Before MCP, connecting an agent to a database required custom integration for every combination. MCP collapses this to a single standard. The AI discovers available tools automatically and calls them as needed. In December 2025, Anthropic donated MCP to the Linux Foundation, and it's now backed by OpenAI and Block as well. It's becoming the industry standard. Second is RAG, Retrieval-Augmented Generation. Instead of hoping the AI knows something from training, you find relevant information and inject it into the prompt. It's an open book exam instead of a closed book one. The pipeline has two phases. During ingestion, you load documents, chunk them into smaller pieces, convert each chunk into a vector using an embedding model, and store everything in a vector database. During querying, you embed the question, find similar vectors, and inject the best matches into the AI's prompt. The chunking strategy matters enormously. Fixed-size chunks are simple but cut mid-sentence. Recursive chunking splits by paragraphs, then sentences. This works for 80% of cases. Semantic chunking detects topic shifts and improves recall by up to 9%. Start with recursive chunking at 512 tokens with 50 token overlap. For embedding models, OpenAI's Text Embedding 3 Small is the sweet spot, just 2 cents per million tokens. You can embed 50,000 chunks for about 50 cents. If you want zero cost, run Nomic Embed Text locally via Ollama. Third is the vector database. Here's the honest comparison. ChromaDB is the easiest to start, pip install and go. Great for prototyping. Qdrant, written in Rust, is the best for local production. Fast, feature-rich, has an official MCP server, and the Reddit community loves it. Weaviate has the best built-in hybrid search. Pinecone is easiest for managed cloud, and if you already use PostgreSQL, just add pgvector. Don't introduce another database. The architecture connects like this. Your AI agent runs an MCP client. It connects to your knowledge base MCP server over standard I/O. The server exposes three tools: ingest text, ingest URL, and search. When ingesting, it chunks the content, embeds it via OpenAI, and stores vectors in ChromaDB or Qdrant. When searching, it embeds the query, finds similar vectors, and returns relevant chunks with metadata. Getting started takes about 15 minutes. Install ChromaDB, OpenAI, and MCP. Create a Python MCP server with ingest and search tools. Configure it in Claude Desktop or OpenClaw. Your agent immediately gains persistent memory. Watch out for common pitfalls. Chunk size too small means chunks lack context. Too large means poor precision. Never mix embedding models. Vectors from different models live in incompatible spaces. Add relevance thresholds to drop low-quality results, and always include re-ranking in production. It bumps precision from 70 to 80% to over 90%. The community is enthusiastic. MCP adoption is exploding across the ecosystem. Vector databases are consolidating around Qdrant, Pinecone, Weaviate, and Milvus, and RAG is the #1 enterprise LLM use case. For building an agent knowledge base, skip the frameworks. Build directly with ChromaDB, OpenAI, and MCP. When your needs grow, Llama Index is the natural next step. It was literally designed for connecting LLMs to